Welcome everyone to this webinar for Factory Design Utilities. I'm excited to take this time to talk to you about the technology that's available for designing an efficient factory layout using Autodesk, and discuss what the integrated factory is. If you're a lean manufacturer, stick around and observe the tools for running Kaizen events, big and small. Watch as we try what-if scenarios on the fly and instantly view results for continual process improvement. I only have a few slides to speak to before diving into the demonstration of the software. In about 10 minutes, I'm going to walk you through a typical workflow for using Autodesk Factory Utilities. Everything from creating a concept to equipment installation and commissioning. We're going to use this facility that I'm walking through now, and I have a lot to show in there coming up soon. So why are we talking about factory? There seems to be a universal truth in the world of engineering and manufacturing, and it can even be simplified into one word, and that's change. Engineering is about change, manufacturing deals with change. There are changes in demand, shorter product life cycles, increasing complexity with products. There are new technologies in manufacturing such as additive or 3D printing. And Autodesk understands that design isn't just about coming up with a great idea and modeling it in Inventor. After it's released, it's time to make it, and I'm about to show you how it's done. How is Autodesk going to help? Autodesk helps by addressing the entire factory lifecycle, starting with plan. Like conceptualizing a product, there's a concept for the factory layout as well. Think about how some of you are doing it today. Engineers will begin concepts in various ways, such as hand sketches or physical blocks that can be moved around on a conference room table. Are you using calculators or spreadsheets to analyze your throughput? Well, in a minute, I'm going to show you a great tool for conceptualizing your layout before it goes to the design phase. Many of you are familiar with using AutoCAD for your 2D layout design, which is great. Let me show you other tools that are available within AutoCAD for analyzing material flow and even displaying your layout in 3D. With validation, design reviews and clash management can be done in 3D, which is great for the designer as well as stakeholders who have a hard time reading 2D drawings. And now that you have a great design, it's time to install or change the equipment around. And that can all be managed or scheduled right in Navisworks. Even import an existing spreadsheet into the system if it's created in another application or directly in Excel. And then finally operate. In this phase of the factory lifecycle, we can leverage the factory model by linking master data to the geometry. Master data such as processes, setup, and downtimes of the factory assets can be linked back to the model. And tie all of this together using cloud services. Say, for example, we have a production line in Europe and they want to build the same production line in Africa. They can reuse the same asset library because it's stored in the cloud. There's no need to set up a common server to accomplish this. Taking a look at the top of this slide, you can see the factory lifecycle that we just spoke about. First, the engineers are creating a product, they're designing it and validating it until it's ready for production. Later, somebody takes care of the processes needed to make the final product. And even later, someone takes care of the resource planning and execution. Time to market, cost to market, and quality are key in plan, design, and validate. And remember what I said earlier about the product lifecycle becoming shorter and shorter. How are engineers going to address that challenge? Then when the product is ready and the resources are ready, it's time to start up production for the job or project and ramp it up to full-scale production. Right here, everyone is looking to reduce time to volume. Already, most of them are working over the weekends to get to full production. So where can we find room for improvement? After reaching full-scale production, they hand it over to the operators of the factory. Then they have to take care of it in an efficient manner until the end of production or the end of the product lifecycle. In the operate phase, the operations manager is looking to increase overall equipment efficiency. And overall, what we're trying to do here is use Autodesk Factory Design Utilities to help make more informed design decisions during the entire product lifecycle. We are helping engineers to design the product, establish the process, and obtain the resources they need almost in parallel to each other, or a more concurrent environment, in turn reducing the time to volume. Production can begin sooner. Through validation, they can reach full production in a shorter period of time. Let's dig a little deeper and find out what this looks like using Autodesk Factory Design Utilities. Then we'll show a demonstration of the software. Normally, our customers begin with a 2D layout in AutoCAD and optimize the layout there. But if we start with a process concept and an easy-to-use interface, then we can move away from Excel or manually moving blocks in a conference room table. Then we can provide throughputs, downtimes, or bottlenecks to the rest of the team. We can help them to improve the process concept, all before we go to an actual 2D layout in AutoCAD. Then when we have the 2D layout ready to go, we can then sync it with factory assets in 3D. And then bring in additional 3D facility data such as point cloud or scanned images of the building if necessary. Then later, if we have it, we can bring in the BIM facility information. And all that to say, we're going from a 2D layout to an integrated 3D layout. Then we can do things like class detection of the equipment, schedule and simulate the installation process. And finally, we can create a closed-loop integrated factory model by linking the data from the physical machines back to the 3D model. This helps to optimize the current production, and the data can be utilized to better plan for the next project. That data can be fed directly to the asset library for a more accurate future process concept. Okay, enough of the slides. Let's take a look at a demonstration. Hopefully that at least provided some insight to what Autodesk is doing to address some of the challenges with making products in the factory. Okay, I'm going to use this VMEG facility as an example for what we want to show in factory today. We're going to start by doing a virtual walkthrough of the building, and these walkthroughs help stakeholders visualize the equipment in the building rather than attempting to understand the 2D drawing. All the equipment you see has been dragged into the layout from our factory asset warehouse. It can be done in the 2D or 3D environment, as you'll see in just a few minutes. Right now, we're walking through the area where the ATVs are assembled. And then next, we'll head over to the other side of the building where we're cutting and welding components. Now let's pretend we have a situation where there is an increase in demand for more of these ATVs. How are we going to go from making 20 of these to, say, 200? The chassis, for example, can no longer be welded by hand to get the job done on time. We need a system that is more automated like a welding cell. Utilize robots on an indexing table. Okay, so we're going to find out what we can do with this empty space right in front of us. We're going to begin by developing a process concept before incorporating it into our building layout. What you are seeing is a web-based product that helps manufacturing engineers and system designers model, study, and optimize the manufacturing process. Here we can take advantage of existing data from the shop floor to populate the study, or we could use the toolbar for dragging new block diagrams or equipment into the workspace. We'll start by testing a single weld cell for the chassis, and the goal here is to find out how many we can make in an 8-hour shift. Perhaps we have a goal in mind to make 100. The assets that I'm dragging in are coming directly from the same library that we'll be using in AutoCAD and Inventor. All the properties we need are available for the source material, processors, and buffers. You can see the final product at the end, which is our weld chassis. Then there is the source material, or the parts being welded together. In the middle, we have each of the processes, the parts being added to the weld fixture, the welding cell, and unloading the finished product to a pallet. Let's change a couple properties before running this thing. The source material is merging into one item, and the 3 operations on the welding station happen sequentially. Then once again, we are going to find out how many of these we can make in an 8-hour shift. Okay, let's run the analysis and see what we get. If 76 products isn't going to be enough, let's try 2 cells by copying the asset. It's just a simple copy and paste. Then we can connect the new processes. These lines that you're seeing are the transportation modes. They also contain property information for things like time, lot size, and capacity. Then we can run the analysis again and quickly come up with a new throughput. Now we have 113, which is great. Then we can also look at a report to analyze the efficiency of the equipment in the process. Find out if anything in the system is over or underutilized. Now that we are happy with the process concept, we can export it directly to a DWG and utilize it in AutoCAD. And this is possible because each of the blocks in the diagram have assets connected to them from the asset library. Now here in AutoCAD, we'll open our existing factory layout. Here is the second portion of the building you saw in the walkthrough earlier. We're going to make sure that we can fit both of the weld cells in the empty space. We'll start by bringing in one weld cell and copy it for the second one. We'll rotate and move the second one in place. And move both into position. As we move the equipment in place, we're going to ensure it doesn't interfere with other assets or building structures. This is AutoCAD architecture, which of course provides the ability to model all the components of the building as well. Additional items can be included in our weld cell. Let's edit one of them. I'm going to add a few roller conveyors. The factory library contains thousands of categorized assets to choose from. Sometimes I find it easier to search for what I need. We'll bring in a couple curved and straight conveyors to put our weld fixture on, and save that. And there's one other thing I want to talk about before taking a look at this in 3D. Also gain valuable information for transportation costs and machine utilization. Beginning with transportation, what is the cost, travel time, and distance based on means of transportation between stations? This is a great place to run a mini Kaizen event. What about machine utilization? Look for bottlenecks in the system, make changes to operations, and immediately observe the results for an efficient material flow. Now that I'm happy with the two weld cells, let's take a look at it in 3D. Remember, there is bidirectional associativity in 2D and 3D. Make changes or add assets in either environment and they will remain in sync. And as you're about to see, adding equipment in 3D is very similar to 2D, except you can visualize it better. There's our two weld cells, which are looking good. Now let's bring in a couple jib cranes for transferring the weld fixture to and from the weld table. The asset library is the same exact library we used in AutoCAD. Basically speaking, each asset contains a 2D and 3D version. As you can see, all the work is done in the graphics view for positioning and orienting the factory equipment. As long as you know where it goes, this is something that anyone on the team can do. Bringing equipment into the factory layout is just the beginning of what you can do in 3D. There's more that I want to show you inside Navisworks, things like class detection management tools, walkthroughs, and scheduling the installation of the factory plan. This is what we were looking at the beginning of the demo. Once again, stakeholders will benefit from a virtual walkthrough of the facility. As new equipment is added within the 2D or 3D environment, Navisworks immediately reflects those changes. And there's no better way to dynamically visualize the virtual factory by incorporating a digital mockup. Mechanical and manufacturing engineering teams can now collaborate more effectively and efficiently make more informed factory layout decisions before any equipment is installed. So here we are at the new layout design with the weld cells included. You can see we also have point cloud data representing the existing building. We can take advantage of scanned point cloud data from the existing facility to ensure the equipment doesn't interfere with overhead building structures, I-beams, HVAC, or piping. And if there is a problem, then remember modifications can be made in the 2D or 3D environment. We can see this is an issue between the jib crane and the building structure. From here, we can change the properties of the existing equipment or try other options from the factory asset warehouse. You can see here we have the properties for the crane. And right now, we have the options for the height and length. Remember that any dimension or variable can be included in these property fields for changing the asset. Now back in Navisworks, it's important to note that this is a clash detection management tool. Not only does it find clashes, it also keeps a record of clashes that have been resolved. Even assign clashes to a team member. And generate a report for everyone to review. When it comes to installation and commissioning, we can take advantage of the drawing capabilities for documenting the layout. Place the desired views on the sheet, even scale the views by dragging the border or change the view orientation when needed. Display the isometric view in color for better collaboration with those who have a difficult time reading 2D drawings. Produce a bill of equipment automatically. As factory assets are added or removed from the design, the parts will update accordingly. Even add the balloons for the equipment. Let the software find each BOM item to place them automatically. After the factory equipment has been planned out, we begin the install and commissioning process for the new factory layout. With the planning tool, we can manually add the items, but we found that several organizations want to open up the install plan to a larger team. Thus, tools like Microsoft Project or Excel can be used to develop the install plan. Our plan is to install the welding indexing tables, then followed by the robots, the controllers for the robots, the safety equipment, or the safety fences in this case, the conveyors, and finally the cranes, which we're using to transfer the chassis components from the conveyors to the welding table. We can connect the 3D model to the schedule for a better integration between the timeline and our digital mockup. Then we can also simulate it when we're finished. Here we can scrub the timeline or play through the video. Once the team is comfortable with the process, we will capture the animation and share the AVI for everyone to open and review as needed. Basically speaking, Autodesk Factory Design Utilities is a complete workflow. Analyze your processes, strategically position and validate the equipment, and plan for installation. Well, that concludes the demonstration. The question is, how do you get your hands on these tools for factory? It's all part of a collection we call Product Design and Manufacturing Collection. It's everything the engineer needs to design and make products. Tools like Nastran and CAD for advanced simulation, thermal, fatigue, and nonlinear analyses. HSM for creating machine toolpaths. Recap Pro for capturing and organizing point cloud data for your factory layout. And Volt to manage all your data in a secure environment. It's all there in the Autodesk Product Design and Manufacturing Collection. Well, that about wraps it up. I want to thank everyone once again for joining us for this webinar for Factory Design Utilities. Please feel free to contact me directly if you have any questions, or you would like some help finding a local representative. My email address is jim.byrne@autodesk.com. I'm looking forward to hearing from you. Have a great day.